We are here with new episode. Mercury, the smallest and closest planet to the Sun, has long been a mystery. For centuries, astronomers could only speculate about its surface, but with advancements in space exploration, we now have a clearer picture of this strange world. Surprisingly, scientists have found evidence suggesting the presence of diamonds on Mercury, a discovery that challenges everything we thought we knew about this scorching planet. But this is only one of the many bizarre aspects of Mercury. Its core is unexpectedly large, its surface conceals geological secrets, and its orbit defies expectations. What makes Mercury so different from the other planets, and what other hidden wonders might it be keeping from us? The first real glimpse of Mercury came in 1973 when NASA's Mariner 10 mission sent back images of the planet. These revealed a landscape covered in craters, much like the Moon, along with ridges and strange formations. Scientists also discovered that Mercury had a surprisingly strong magnetic field and a core that was much larger than expected. These findings contradicted earlier theories about the planet's composition, suggesting that there was much more to learn. Decades later, NASA sent another mission, Messenger, which orbited Mercury for the first time in history. This spacecraft captured over 200,000 images, giving scientists an unprecedented view of Mercury's surface. One of the most intriguing discoveries made by Messenger was the presence of high concentrations of calcium and magnesium on the darker side of the planet. This raised questions about how these elements ended up there. Mercury's magnetic field was also found to be stronger in the northern hemisphere than in the south, another unexpected finding that indicated its internal structure was unlike any other planet in the solar system. Mercury's extreme conditions make it a unique world. With daytime temperatures reaching up to 430 degrees Celsius (806 degrees Fahrenheit), it is hot enough to melt lead, yet at night, the temperature drops to a freezing -180 degrees Celsius (292 degrees Fahrenheit). This dramatic shift occurs because Mercury has a very thin atmosphere, called an exosphere, which cannot trap heat. Scientists once believed that Mercury was a dead world with no geological activity, but in 2012, Messenger data revealed evidence of volcanic eruptions. There were signs of explosive volcanism, with pyroclastic deposits that indicated Mercury was once geologically active. Even more shocking was the discovery in 2020 of water ice, hidden in permanently shadowed craters near the planet's poles. Despite being so close to the Sun, these craters never receive direct sunlight, allowing ice to remain frozen. This raised an even more fascinating question. Could there be microscopic life forms, like the extremophiles that survive in harsh environments on Earth, hidden in these icy regions? Mercury's mysteries extend beyond its surface. One of the strangest things about the planet is that a single day on Mercury is actually longer than its year. It takes only 88 Earth days for Mercury to complete one orbit around the Sun, but it takes 176 Earth days for it to rotate once on its axis. This means that Mercury experiences just one full day every 2 years. If someone were standing on Mercury's surface, they would see the Sun rise, stop in the sky, move backward for a while, then continue moving forward again. This happens because Mercury's rotation is locked in a rare 3:2 spin-orbit resonance, meaning it rotates 3 times for every 2 orbits around the Sun. Scientists believe this unusual rotation is the result of the Sun's gravitational pull, which has slowed Mercury's spin over billions of years. Mercury's weak atmosphere, or exosphere, is another unusual feature. Unlike Earth, which has a thick atmosphere, Mercury's is made up of just a thin layer of particles that are constantly being lost to space and replenished by solar wind and micrometeorite impacts. The presence of water vapor in this exosphere, detected in 2020, was another surprising discovery. Scientists believe that hydrogen from the solar wind reacts with oxygen in Mercury's surface rocks to produce this water vapor. The planet's magnetic field, though much weaker than Earth's, plays a crucial role in shielding its surface from the constant bombardment of solar particles. This protective magnetic field is generated by the movement of liquid metal in Mercury's core, which is an unusual finding for such a small, slow-rotating planet. Mercury's extreme conditions create hot and cold spots on its surface. Some areas, called hot poles, experience the most intense heat because the Sun appears to pause in the sky there for long periods. At the same time, other regions, like craters near the poles, never receive sunlight and remain frozen. These permanently shadowed regions are where scientists have discovered water ice, an extraordinary finding for a planet so close to the Sun. The presence of ice has led researchers to wonder whether other volatile substances, like organic compounds, might also be hidden in these frigid traps. The Bepi-Colombo spacecraft, launched in 2018 as a joint mission by the European Space Agency and the Japan Aerospace Exploration Agency, is on its way to Mercury and will arrive in 2025. This mission aims to study Mercury's surface composition and uncover more details about its history. Because Mercury orbits the Sun so quickly, reaching it is a challenge. Bepi-Colombo has to perform multiple flybys of Venus and Mercury itself to slow down enough to enter orbit. One of Mercury's most baffling secrets is its disproportionately large core. While Earth's core makes up about 15% of its volume, Mercury's core accounts for about 85% of the planet's total mass. Scientists have proposed a theory called the hit-and-run hypothesis to explain this. According to this idea, Mercury may have once been a much larger planet that was struck by another large celestial body. This massive impact could have stripped away much of Mercury's outer layers, leaving behind an unusually large iron-rich core. This theory is supported by the presence of volatile elements, such as sulfur, potassium, and sodium, found on Mercury's surface, elements that should have evaporated long ago due to the planet's proximity to the Sun. Their presence suggests that Mercury's outer layers may have been blasted away, exposing deeper layers of material. Scientists have also been puzzled by Mercury's offset magnetic field, which is shifted about 20% north of the planet's center. This unusual positioning may be due to variations in the thickness of Mercury's crust, which could influence how heat escapes from the planet's interior. Another discovery that defies expectations is Mercury's geological activity. While scientists once believed it was a dead world, the MESSENGER mission revealed bright, shallow depressions called hollows that suggest ongoing geological processes. These hollows could be areas where volatile materials are escaping from Mercury's interior. Even more striking is the planet's chaotic terrain, an area of jumbled hills and valleys. Some researchers believe this unusual landscape was created by powerful seismic activity caused by tidal forces from the Sun. Mercury's strange properties make it one of the most intriguing planets in our solar system. Its unusual orbit, massive core, and unexpectedly active surface challenge scientists' understanding of planetary formation. The discovery of ice and organic compounds raises questions about the potential for life, even in the harshest environments. Future missions like Bepi-Colombo will help us unlock more of Mercury's secrets, but for now, this small, scorching world remains one of the most enigmatic places in our solar system. Despite being the least explored of the inner planets, every new discovery about Mercury adds to the growing realization that it is far more complex and mysterious than we ever imagined. Mercury's deep secrets challenge our understanding of how planets form and evolve. Even though it is one of the closest planets to us, there are still countless mysteries waiting to be uncovered. With future space missions and advanced technology, scientists continue to explore what lies beneath Mercury's cratered surface, hoping to reveal new and surprising discoveries. Recent findings suggest that Mercury's subsurface holds just as many secrets as its visible surface. One of the most fascinating aspects of its interior is the structure of its core. Unlike Earth, which has a solid inner core surrounded by a liquid outer core, Mercury's core is mostly liquid with a solid inner portion. NASA's MESSENGER mission used detailed gravitational field measurements to confirm this unique core composition. Scientists estimate that Mercury's solid inner core is about 1,260 miles, 2,000 kilometers, wide, making up almost half of the planet's total core. This is much larger in proportion compared to Earth's inner core, which only accounts for about 20% of our planet's total core volume. The structure and size of Mercury's core play an essential role in generating its magnetic field. Although Mercury's magnetic field is much weaker than Earth's, it is still unexpectedly strong for such a small planet. Beneath its rocky crust, Mercury has a mantle that is much thinner than previously thought. Research suggests that the mantle is only about 260 miles, 420 kilometers, thick, whereas Earth's mantle extends about 1,800 miles, 2,900 kilometers. This thin layer affects how heat is distributed inside Mercury and impacts its geological activity. Some of the most exciting discoveries about Mercury's subsurface came in 2012 when the Messenger spacecraft detected evidence of ancient volcanic activity. The spacecraft found shallow depressions known as hollows, which likely formed when volatile elements evaporated from the surface. These unusual formations indicate that Mercury once contained more volatile materials than scientists had previously believed. In 2020, researchers studying Messenger's data made another groundbreaking discovery. They found evidence of a vast underground magma reservoir that existed in Mercury's distant past. This ancient ocean of magma played a significant role in shaping the planet's surface and internal structure. The presence of this molten material may explain some of Mercury's most distinctive features, such as the large, smooth plains that cover much of its northern hemisphere. These plains, known as the northern volcanic plains, are believed to have been created by enormous lava flows that occurred billions of years ago. One of the most astonishing findings about Mercury's interior came in 2022 when scientists discovered nitrogen trapped beneath its surface. This nitrogen might be a remnant of an ancient atmosphere that was driven underground due to the planet's extreme heat and constant bombardment by solar radiation. The discovery raises intriguing questions about Mercury's past. Did the planet once have a much thicker atmosphere? If so, what impact might that have had on its early climate, and could it have ever been habitable? Another remarkable discovery involves Mercury's polar regions, where water ice has been found in permanently shadowed craters. Although this ice is located on the surface, it is hidden from direct sunlight and protected by the extreme cold in these permanently dark areas. Some studies suggest that this ice might be relatively young, possibly deposited by comets or asteroids within the last tens of millions of years. In addition to ice, these craters contain dark deposits that scientists believe could be organic compounds. These materials, which are even more volatile than water ice, might be remnants of comets or asteroids that impacted Mercury. The preservation of these organic molecules on Mercury provides valuable insights into the distribution of complex compounds throughout the solar system. Mercury's subsurface also provides clues about its tectonic history. Unlike Earth, Mercury does not have plate tectonics. However, as the planet cooled over time, it contracted, causing its crust to crack and form large thrust faults. These faults, some of which are several kilometers high, provide insights into the planet's geological evolution. Recent studies suggest that Mercury might still be tectonically active today. In 2019, scientists discovered small landforms called grabens near some of Mercury's largest faults. These grabens, which appear as small valleys caused by the stretching of the crust, are relatively young, suggesting that the planet's surface is still shifting and settling. One of Mercury's greatest mysteries is its magnetic field. While Earth's magnetic field is created by the movement of molten iron in its outer core, Mercury's field appears to be generated by a different mechanism. Some researchers believe that it is produced by a thin outer layer of liquid metal surrounding the solid inner core, creating a weak but persistent magnetic field. Another puzzling aspect of Mercury's interior is the possibility of deep fractures that allow heat and possibly even fluids to travel through the crust. While Mercury's surface is completely dry today, some scientists speculate that there might be pockets of liquid water deep underground, kept warm by heat from the planet's core. Although it may seem unlikely, the idea of subsurface water on Mercury is not entirely impossible. Other seemingly uninhabitable places in the solar system, such as Jupiter's moon Europa and Saturn's moon Enceladus, are known to have liquid oceans hidden beneath their icy crusts. While Mercury is vastly different in terms of environment, the possibility of liquid water remains an open question that scientists continue to explore. As research into Mercury's hidden depths continues, new questions emerge. How has its internal structure evolved over time? Could other volatile elements or compounds be hidden beneath the surface? What can Mercury's geological history tell us about the early solar system and the forces that shaped the inner planets? These mysteries highlight the importance of future missions to Mercury. Each discovery adds to our understanding of planetary formation and evolution, providing valuable insights not just about Mercury but about the entire solar system. Despite its small size and extreme conditions, Mercury remains one of the most intriguing planets. Its hidden depths could hold the key to understanding its past, and perhaps even the history of our own planet. The more we explore, the the more fascinating Mercury becomes, proving that even the smallest planets can have the biggest secrets. Who knows what we might uncover next? Could there be valuable minerals beneath its surface? Or even traces of ancient extraterrestrial activity?